Algebra 1, this is 8.7. 8.7 is solving quadratics again, but this time, as you can see, we're going to bring an a value in, so it's not equal to 1. These ones are going to handle the exact same way as the last ones with a slight twist. We're not going to just look for factors of c, because it'll never work that way. Because now we have an a value. The a value is going to change the fact that it can't just be x times x. It's going to have to be something x times something x this time to make it work. And so what I'm going to do is I'm going to go back to looking at a quadratic like we have here with the 7x squared, and I'm actually going to break it up and factor by grouping. And factor by grouping will always work. If it's factorable, it'll work. It's going to be kind of nice. So it's something we've already done. We're just going to add a slight twist to it here. Now, before we continue, these can be set equal to 0. So again, once we're done factoring it, we can take each one of those factors, set them equal to 0, and you can solve for the variable, which is mostly x, okay? So, steps. Number 1, so we'll say factoring ax squared plus bx plus c. So we're going to be factoring when a is equal to not 1. Is that interesting? Okay. This is what I want you to do. Multiply a times c. 2. Find the pair that gives b. So we're still going to connect to b, but we're going to connect with not just the factors of a, we're going to look for the factors of a times c. 3, I need you to split up b with that pair. And 4, factor by grouping. And you're done. So here we go. I need to factor this, possibly to solve it or just to factor it. What I'm going to do first is a times c. A was 7, c is 4. 7 times 4 is?
27.
20,
yeah.
not 20. 28, okay. So it's 28. Now I just have to find the factor pairs of 28. 1, 28. 2, 14. 3? No, 3 doesn't work. 4? And 7. Anything else? Any other factor pairs? No. Okay. I now go back and I select which one of these pairs, just like before, would allow me to get a positive 29. Which pair? Which pair is going to add up to a 29? The first one, or 1 and 28. So I'm going to go circle it. And now we are in step, let's see, that this is 3. So now we get to step 3. Step 3 says split up b with that pair. 7x squared plus 28x plus x plus 4. What I just did was I took 29x, using the pair that we decided, 1 and 28. Would you guys agree that 28x plus an x is still 29x?
Yeah.
Did I change the problem by splitting those two apart? I basically uncombined like terms. They're still equivalent equations, yes? Or expressions in this case, because there's not an equal sign. How many terms do we have? 4. What are we going to do? We're going to factor by grouping. So if you need those steps, look back in your notes for them. We're going to go over them here quickly here. The first step of that was put a parentheses around the first two and the last two. And the last two, I want you to include the sign. And then the whole idea is to factor out the greatest common factor in each group. What's the biggest things I can pull out of that first group? Can I pull out of a 7x squared and a 28x? I can't pull 4 out. 7. And? X?
X squared.
Can't pull an x squared out. I can pull an x because 28x only has an x. When I factor out a 7x from 7x squared, what's left? X. If I divide 28x by 7x, I get a 4. Now, remember, I still have to factor something out of that second group. And that second group, though, has to look like the first group. I want this group and this group to look the same. Aren't they looking pretty much the same already?
Yeah.
So what can I pull off or out of this group that will not change it? What's the magical number that I can divide out of something and never change it? 1. So I'm going to pull or factor out a positive 1. That would leave the inside group to be an x plus 4. Notice basically what I did is I factored out the positive. The positive 1. Now the sign's on the outside. That was kind of the reason I like to put the sign in, because I can factor it out. And so, factoring out my common term, which is x plus 4, and pushing together my outsides, you now just factor. And if you don't believe yourself, you do what? 4-letter F word.
Foil.
Foil. You foil those two together, you're going to be fine. Now, again, what happens if this was equal to 0? Then this would equal 0. This would equal 0. And this would equal 0, which means that x plus 4 equals 0. Or you would say x equals negative 4. I think everybody gets that one pretty easily, right?
Yeah.
But also 7x plus 1 equals 0. That one is a little bit trickier because you have to subtract 1 and then divide by 7. This one you might want to show your work and then divide by 7. X actually equals negative 1/7. So the two answers that come from this particular problem is negative 4 and a negative 1/7. Those are your zeros. Those are your solutions. So now we have to factor this one. This one is not factorable. They call it prime when it's not factorable. This method is really kind of nice. If it's not factorable, we're going to be able to find that right away. So we still go through the same process. What's a times c? 4 times 5, which is 20. And we start looking for pairs, right? 1 and 20, 2 and 10, 4 and 5. I think that's it. You just ask yourself, can any of those factor pairs give me a negative 3?
Mm-hmm.
Which one?
The 4 and the 5.
4 and 5. That'd be 4 plus 5, which is 9. 5 minus 4, which is 1. Or 4 minus 5, which is negative 1. Or negative 4 minus 5, which is negative 9. That is not a negative 3. That means none of these pairs will work to give me a negative 3. Therefore, this is prime. You're done.